Hi everyone, so for today we'll be looking at electronic configuration. So we'll be looking at how the electrons are arranged around the atom. So in the previous lesson we've learned how we can find the number of protons, number of electrons and number of neutrons in an atom. So today we'll see how the electrons arrange themselves. So just like we discussed previously, electrons, they are going to be arranged in electron shells, and each electron shell is numbered accordingly. So 1, 2, 3, 4, etc. And each electron shell can hold a specific number of electrons. So the first electron shell will hold up to 2 electrons only. So it can hold 0, it can hold 1, or it can hold 2 electrons, but it will not contain more than 2 electrons. The second energy level will hold up to 8 electrons, so it can hold 0, 1, 2, 3, etc. up to a maximum of 8. The third shell is stable also with up to 8 electrons, so 0, 1, 2, up till 8. Any remaining electron for your level will go in the fourth shell. So you won't have an extraordinary number of remaining electrons. You can have maybe up to 2 remaining electrons. This will go in the fourth energy level. So the first shell contains up to 2, second shell up to 8, third shell up to 8, and the fourth shell will contain the remaining 2 electrons in case you have them. So at your level, this model is going to allow you to fill up only up to 20 electrons in an electron shell. Any element that has more than 20 electrons does not use this kind of model for us to arrange its electron. It uses a little bit more advanced model. So to find the electronic configuration of any atom, first you need to find the number of electrons, and for this we find the number of protons. So from the number of protons we can get the number of electrons, because for an atom, because the atom is neutral, the number of protons is equal to the number of electrons. Now, for us to draw the electronic structure diagram, we are going to first write the symbol of the element at the center, and then we'll have circles that represent the shell. So here the center will have the symbol of the element, circles that represent the shell, and the electrons are either represented using dots or crosses. So in here you have dots. So you see the first shell is filled by 2 electrons only, second shell by a maximum of 8, and the third shell by a maximum of 8. So this one is showing all the shells completely filled. So let's see how we apply this. So we take the first example. We have the element helium. So from this, we know that the proton number, so it's the smaller number, so we have 2 protons. Number of electrons will be the same as the number of protons. And electronic structure will have the symbol at the center, and then we'll have the 2 electrons that we have that fit in the shells. So we'll start filling the electrons starting from the first shell. So the first shell, if you remember, can hold a maximum of 2 electrons. So we have only 2, so they both go in the first shell. So I'm going to use cross to represent the electrons. For us to write the electronic configuration, we'll just write the number of electrons in each shell separated by a comma. So let's say here for this one, the electronic configuration would be first shell has 2, second shell has 8, third shell has 8. So this is how we write electronic configuration. So for helium, the electronic configuration is just going to be 2, because that's just 2 electrons. Let's try another example, fluorine. So fluorine here has 9 protons, Therefore, it will have 9 electrons. The electronic structure will have the symbol at the center, and then we'll start filling in electrons. So we have 9 electrons to fill in total. So from the 9 electrons, the first 2 will go in the first shell. So first shell, let's subtract 2 from this. So the first 2 go in the first shell. Now I have 7 left. The second shell can hold a maximum of 8. So the 7 can all go in the second shell. So I'm going to just fill the 7 in the second shell. So the electronic configuration, first shell contains 2, second shell contains 7. Aluminium, as another example, has 13 protons, so it will have 13 electrons. We'll draw the electronic structure by writing the symbol at the center, so aluminium, and then we'll start filling. So the first 2 electrons go in the first shell. So 13 we filled in the first 2, so we have 11 left. Now out of the 11, only 8 can go in the second shell, so we fill up the 8. So from 11, I have already filled up 8. So I have 3 that is left. The third shell can hold up to 8. So I have 3. I'll just include the 3 electrons. So the electronic configuration is just 2, 8, 3. First shell has 2. Second shell has 8. And third shell has 3. Potassium, if you look now, for this one, you will have to look in the periodic table. So here we have potassium. Potassium here has number of protons 19. So it's a smaller number. So potassium has number of protons 19. So number of electrons will be 19. We'll start by writing the symbol at the center, and then we'll start filling. So first 2 go in the first shell, so I'll minus 2, so I have 17 left. 8 will go in the second shell, so minus 8. From the 9, only 8 can go in the third shell, so I fill up the third shell with 8, so minus 8. I have only 1 left, so that 1 will go in the last shell, the fourth shell. So electronic configuration 2, 8, 8, 1.